Let's start the new year with a beautiful integral. So we are going to solve this integral using the Euler substitution, right? So what the Euler substitution does is to let this radical, that is the square root of x squared plus 2x plus 3, this one to be equal to t plus x. So this is a genius substitution developed by Euler to solve complex integrals. So after doing this, we have to square both sides. Squaring the left hand side is going to be left with 2x plus x squared plus 3, and that is going to be t plus x all squared, right? So x squared plus 2x plus 3 on the left hand side, this is equal to foiling the right hand side is going to be t squared plus 2tx plus x squared. So when we do that, what happens? X squared is going to cancel x squared, right? So what is left is 2x plus 3 on the left hand side, and this is t squared plus 2tx. Now what we are going to do here is to isolate x. So we have 2x minus 2tx, and this is equal to t squared minus 3. Cool. So we can factorize x out, and that is going to be 1, 2 minus 2t, and this is equal to t squared minus 3. So x here is going to be equal to t squared minus 3 all over. You can factorize 2 out here, and that will be 1 minus t, right? So this one is an expression for x that we can replace in our integral here. So this one, in place of x, I'm going to replace it with this. Cool. Now we have to find an expression for the whole of this one in terms of t as well. We know that the square root, that is our substitution, x squared plus 2x plus 3. This is t plus x, right? So this is equal to t plus, so in place of x, I'm going to put this one. That is going to be t plus x, and x is t squared minus 3 all over 2 into 1 minus t, right? So this one is equals to, so we have 2 into 1 minus t times t, and plus t squared minus 3 all over 2 into 1 minus t, like this. So this is equal to, we can FOIL this, and that is going to be 2t minus 2t squared, and then plus t squared minus 3 all over 2 into 1 minus t. Alright, so this is equals to, you can simplify the numerator, so that is going to be 2t minus t squared minus 3 all over 2 into 1 minus t. So this one is an expression for the square root of x squared plus 2x plus 3 in terms of t that we can replace in our integral, that is here. So what is left? We have an expression for x, we have an expression for this, all in terms of t. Now what is left is an expression for dx in terms of t and dt. Let's do that. So let's switch colors, why not? So to find an expression for dx in terms of t, we have to differentiate this using the quotient rule. So dx dt is going to be equal to, using the quotient rule, this is u and this is v. So we know this, so that is v du. So that is 2 into 1 minus t times du. So differentiating u is going to be 2t minus t squared minus 3. And differentiating this, that is going to be negative 2, right? So differentiating the denominator is going to be negative 2, right? All this one divided by the denominator squared. So that's going to be 4 multiplied by 1 minus t squared. So dx dt, let's simplify this one out and see how it looks. So we are going to multiply this one again, and that is going to be 4t, right, minus 4t squared. That is these guys. And then here we are going to have positive 2t squared, and then minus 6. That's negative, negative, negative. That's going to be negative, right? All right, divided by 4 into 1 minus t all squared. And this one is equals to, simplifying the numerator, that is going to be 4t minus 2t squared minus 6. All this one divided by 4 into 1 minus t squared. And this is equals to what? So we can factorize 2 out, which is common, and then we are left with 2t minus t squared minus 3 all over 4 into 1 minus t all squared. So dx here is going to be equal to 2t minus t squared minus 3. All this one divided by 2 into 1 minus t all squared, and then dt. So you see that 2 is going to cancel 4 here, leaving 2. Right, now we have an expression for x in terms of t, we have an expression for this in terms of t, and we have an expression for dx in terms of t. So the integral is now going to look like this in the t world. I is going to be equal to the integral of 1 all over, so when we go up, 1 all over x, right? So what is x in terms of t? X in terms of t is this. So that is t squared minus 3. So this is t squared minus 3 all over 2 times 1 minus t. 2 times 1 minus t. This is multiplied by the square root of x squared plus 2x plus 3. And that is equal to this in terms of t. So that one is equals to 2t minus t squared minus 3. That is 2t minus t squared minus 3 all over 2 into 1 minus t. 2 into 1 minus t, like this. So these ones are multiplying each other. Multiplied by dx. The expression for dx in terms of t and dt is 2t minus t squared minus 3 all over 2 into 1 minus t all squared, and then dt. Nice and sweet. So here there will be some cancellations. So we see that 2t minus t squared minus 3 is going to cancel this one nicely, right? And t 1 minus t all squared is going to cancel the product of this and this, right? And we have 2 here, which is going to cancel this 2, right? So the integral is now left with this. I is going to be equal to the integral of 1 all over, what is left at the denominator is t squared minus 3 all over 2 dt. That is what is left, because everything has cancelled and is left with t squared minus 3 over 2 at the bottom, right? As simple as that. So you see that here we can multiply top and bottom by 2, and that is going to be the integral of 2 all over t squared minus 3. So this is how this integral is simplified. See, very easy. So now let's solve this. 2 is a constant. Pull it out of the integral. The integral of 1 all over t squared minus 3 dt. I'm going to convert this one to the tan hyperbolic inverse integral. So we have I to be equal to, so I'm going to multiply the top by -1 and then multiply the bottom by -1 as well. So when I multiply the bottom by -1, that is going to be 3 minus t squared, like this dt. And this is going to be -2 out. The integral of 1 all over 3 can be written as the square root of 3 squared, and this one minus t squared dt. And now let me compare this one to the arctan hyperbolic integral. So if we have the integral of 1 all over a constant a squared minus a variable x squared dx, this is the same as 1 all over a, the tan hyperbolic inverse of x over a, right? So we are going to use this to solve our integral. So a, the constant here is 1 over the square root of 3. Square root of 3 is the constant, sorry about that. And then we have the tan hyperbolic inverse of x. X here, our variable here is t all over the square root of 3. We are done. We can put the constant of integration. Why not? So this is what our integral has been reduced to. So now what is the value of t, right? So we have to go back to what t is. So when we go back to our substitution, the whole of this was equal to t plus x. So for me to find an expression for t, I have to subtract x from both sides, right? So recall our substitution. All right. So our substitution was the square root of x squared plus 2x plus 3. This was equal to t plus x, right? So that implies that t is equals to the square root of x squared plus 2x plus 3 minus x. So in place of t, I am going to replace it with this guy, right? So now let's do that. So the integral I is going to be equal to negative 2 times 1 all over the square root of 3, and then the tan hyperbolic inverse of t, and t is the square root of x squared plus 2x plus 3 minus x all over the square root of 3, and this one plus the constant of integration, right? So this is what we have. So the integral is just negative 2 over the square root of 3, the tan hyperbolic inverse of the square root of x squared plus 2x plus 3 minus x all over the square root of 3 plus the constant of integration. And this one is the answer to this integral. And that is the trick that was developed by Euler to solve complicated integrals. Yeah, so that is the trick that I wanted to show you. So if you really learned something new today, please give me a thumbs up and consider subscribing to Calculus Diaries for more engaging tutorials and tricks to solving integrals. I thank you so much for watching this video, and then I will see you in the next one. Happy New Year. Bye bye.